So we're gonna start going through here and trying to knock out some of the questions that we had. One of the main questions that we kind of had was around why REV Robotics is a company and why we're partnered with FIRST and why we work with FIRST. So REV was actually created by two friends, Greg and David. Greg was a participant on our FIRST team and then mentored teams here in the United States. After graduating high school, David got involved when he was in his undergraduate at the University of Texas, basically, and got to see how much FIRST had an impact on people here across here in the United States, and started to realize that there were a lot of barriers to being able to get in here, not only here domestically, but everywhere across the world, which then kind of eventually leads to the involvement with FIRST Global. And then a lot of folks that actually work here have experience working with FIRST teams or have been alumni. So like I was on a team back home in Michigan.
I was on a team in Austin. I've started FLL teams, currently mentor a team. It's, FIRST has had a huge impact on my life, and, and it's going to have a huge impact on all of your lives too.
Yeah, so it's a way where us as a company, we're able to be involved, we're able to be involved, finding ways where we're able to make robot parts and educational robot parts cheaper. So we're able to get more people to be able to participate in every corner of the globe. And it's one of the big treats, at least for me, and I think Frank can say that for the same thing, is I absolutely love going to the FIRST Global events and seeing all of you, like all these students from all over the place that are so excited about robots. It's not like when there's like cultural stereotypes here in the United States.
It's not just robots, right? Yeah. It's being excited about STEM. It's being excited about creativity, learning, discovery, the whole thing.
Yeah, which is something that's really, really great. So it's one way that we're able to continue to work with FIRST. We're able to continue to try to support these types of programs and hopefully make these things more accessible everywhere. So we're continuing to do hard work to design new products, find better ways of designing our old products, of making our old products to make them more affordable, make them just a little bit easier to be able to get distribution in a lot of places, because we know it can be quite difficult to be able to find replacement parts in places if your robot happens to have a little bit of a happy accident somewhere. So that's just a little bit about REV. The name actually doesn't really, one of the other big questions that we kept getting was about our name, which doesn't actually mean really much of anything. It's actually a pronoun for like revolve or revolution or revision, which are big things that happen within the engineering process.
Yeah, it's all about the process, right? You guys are discovering how to build robots. You guys are discovering how to think about engineering problems, and that process is what the REV name is about.
So we're going to move this over here. So with that, that kind of gives you a little bit of an overview of who we are, who REV is, and where we're at, and where we kind of come from. And then what we can do is be able to move into that's not what I wanted to do. That's not what I wanted. Anyway, this is what I wanted. There we go. So one of the things that we're able to look into for is kind of getting into the basics of kind of design and robot design. So one of the large questions that came up repeatedly from people actually all across the world. I think we had someone from, I think it was like Pakistan. I think it was Bosnia. There's a few other places. They were all asking, generally speaking, what our design process is here at REV, and what we could kind of like say, like when you're starting your design, where do you begin? Because it is kind of you get a challenge and there's a blank slate, and it can be quite daunting or quite intimidating. So I'm gonna let Frank talk about that a little bit.
So the design process is really about understanding what your constraints are and what your goals are. So in FIRST Global, your constraints are what comes in your kit, right? And your goals are what the competition is. So you start with those big picture things. and then you break it apart into different subsections. We need to be able to drive around on the field. Okay, we need a drivetrain. Now let's break down the problems associated with a drivetrain. We need wheels, we need gears, we need whatever. And you do the same thing with your intake. Okay, we have an intake, we want it to achieve this. You want to start big and then pare it down into manageable independent subsections. When we design for REV, we do something very similar. But instead of having a big competition that we're designing a specific thing for, we have the entirety of building robots that we're designing for. And based on our experience being involved in FIRST, based on the conversations we have with teams, we get ideas. We see a team do something interesting or have a lot of trouble doing something that they're wanting to do. And from that, we say, okay, these are our, this is our goal. These are the constraints we have. It needs to be a certain price. It needs to be, a certain, all these, quality, reliability things. Accessibility is a big one. And then we design around those constraints to achieve our goal. So it's one of the big things in the engineering design process is the idea of it being a circular process. You're not done designing once you've got something that works. You want to, start over, right? Okay, I've got something that works. Let me see if I can make it better. Let me see if I can make it better. Let me see if I can make it better. So don't stop yourself once you've got something that works. Also, don't go down a rabbit hole, but you want to continuously iterate. Again, to go back to the name, right? REV. You want to make revisions.
Yeah, and one of the other big things too is Frank kind of mentioned this is with the rabbit hole is it's usually really good at the start of your process to lay out some goals, some things that you want to achieve. So like here at REV, when we're designing products, some of those are cost constraints. We want to make sure that we're able to keep things affordable. There are material selection, a few other things like along those lines. Now with robots and the robot kits themselves, they tend to be a little bit more, those constraints are, some of those decisions are already made for you to some degree, and there is a little bit less choice, but it kind of makes the decisions a little bit easier, right? So you don't have an overwhelming amount of choice. You can kind of sit with the few options that you have. So that's the one thing to kind of start with is clearly defining your goals. And then the second thing is, Frank mentioned this, is like with us, we take an inspiration from you all. We look at what robots are being made, what clever things teams are doing with the kits that they're given, the creativity that they're showing, and we can kind of incorporate that into designs and products. But with everybody else, it's a really good way of being able to do research is looking around in the community around you, seeing, if you have an application where it's like, for example, last year with Ocean Opportunities, you had to grab these balls of varying sizes and move them high and low into these different locations. So if it is, your local community, maybe there is a tractor or a, piece of heavy machinery that is used to do this. Maybe there's something clever that your parents do in their kitchen while they're cooking, or there's a utensil and that type of application that would be able to use some of the base ideas, because a lot of these things come down to some basic pieces of mechanics are seen all around the world in all different applications. So you can take those as inspiration to then being able to tie it back into your own designs.
Yeah, and look at what other teams do. This is a collaborative competition, right? We're all in this together. There's, you want to take inspiration from other people. Don't feel like that's a problem. It's a good thing to do.
So let's see here. So one of the big questions that we have is coming actually from Team Libya. And I think this is going to be a good one for Frank to be able to answer, which is, does making a 3D design for the robot before we build it really make a difference?
And the answer to that is it makes a huge difference. It makes all the difference in the world. Being able to prototype something in a computer lets you make all of the mistakes for free, right? Not only do you have, the ability to see how long a piece of material should be without having to cut it, but you also have a superpower, and that's the Control Z button, right? You can undo any mistake and you can redo something different. You can try all of these things in a virtual environment really quite easily. And it lets you figure out the problems before you spend a bunch of time, because modeling up something in CAD, I know at the beginning it seems like it's easier to do it physically. But as you get better, as you practice with CAD, you will find that you can mock something up much faster in a CAD program than you can in real life. So you can try all of these ideas much more quickly.
And one of the other things is, like, if you don't have access to a 3D design software, it doesn't necessarily mean that you shouldn't be thinking about your design ahead of time. So there are things like, one of the big things that Frank is mentioning is like scale. Scale is really, really important for you to get a handle on. In the computer, it makes some of these things faster and easier. But if you're using like grid paper and you have a scale that you're using where each piece of the grid is equal to, 1 millimeter or 5 millimeters or a centimeter or some unit of measure, you're able to then take that and apply it to the real world. So you can sit down and say, you have a ball, which is going to be 40 millimeters in diameter, and you can draw out with a compass what that is. And you can kind of see what the minimums are going to need to be before you even get started. So you don't have to cut. And it's also, you don't have to cut anything. You don't have to you don't have to spend the time assembling things. And you can kind of get an idea of what the thing is going to look like before you actually sit down to build the object itself.
Yeah, going back to that iterative circular process, right? You want to make those circles. You want to go back, reevaluate your assumptions, reevaluate your process, reevaluate your design as quickly as possible. Because the more of those iterations you do, the better thing you're going to have. And CAD lets you do that. I actually wanted to share, some examples, of things that we've got, mocked up in CAD. Here's a drivetrain example. Here's another drivetrain example. These are all different things that you can relatively quickly do in a CAD program and figure out exactly which brackets you need, figure out where all the nuts and the screws need to go to make all of these things possible. It is a tool to help you come to your design faster. And when you get there, it's going to be more thought out, it's going to be stronger, it's going to be more reliable. So again, to answer that question, yes, it makes a huge difference. It makes all the difference in the world. And I believe we're going to be doing another live stream in the coming weeks, specifically on CAD design using SolidWorks XDesign.
Yep.
And that'll, we'll go over some topics like Crayola CAD and doing assemblies using XDesign. So that'll be really cool.
Yeah, and so that will be able to give a little bit of an intro, some training, from us here to be able to kind of walk through that tool. Every First Global team has access to XDesign. So thanks to SolidWorks for giving these licenses. And the really great thing about XDesign itself is it is not limited by the computer you're using. So a lot of CAD software packages themselves may be limited by the power and the capability of the individual machine that they're running on, where this is actually operated out of a web browser. So as long as you have an internet connection, that is one of the limitations. But if you have the access to the internet, you're able to kind of model and share your designs with the other members of your team. And the other really great thing, and I think this is the other thing as well, is this is a team-based project. A lot of projects that you're going to be working on as you move forward in your lives and hopefully go into careers in science and technology, you will be working in teams, and having the ability of showing somebody something you've designed in a virtual environment or a drawing allows you to be able to get feedback from them, and they can ask questions and potentially point out things that maybe might be issues.
You're not going to get everything right the first time, right?
Yeah. Not everybody is perfect. Not even us here at REV. We do learn things from time to time. That's the reason why there are like, you'll see like V2 or V3 on items on our website, for example, that might be updates, or like in bill of materials, they're versions. It's version 2, it's version 3 of items. And we even keep ourselves to that standard where we do take a hard critical look at a lot of our stuff and be able to try to figure out better ways to be able to do it moving forward, and designing new things that potentially can help take care of some of those issues.
Yep.
One of the things that was pointed, one of the questions, I don't remember which team, and I can't seem to find it in my list, was actually how to build a better claw was one of them. One of the builds was having a better claw. So actually, if we can actually transition to this. So we have ourselves this little guy. So one of the things that is kind of nifty about this is the claw itself. When the servo gets moved, both these wings kind of come, both sides of the claw kind of come forward to then being able to collapse on whatever object you're on or using. So this is using a few of our newer products that we've come out with recently, but you can simulate and do this as well with the ones that you already have in your kit. There are rod ends are in there, I believe, yep, along with, and you're able to put those into pieces of extrusion, as an example, like tapping those into the end to be able to do what is called a linkage. And in particular, this is a 4-bar linkage. Which is
one of the most useful types of linkages out there. If you go on Wikipedia or just search on Google 4-bar linkage, you can see examples of how it's used in just tons and tons of ubiquitous things that you just don't think about.
Yeah, and one of the big things with a 4-bar linkage is that these two faces, so with this case, it is this line of the structure that it's mounted to, and this face, which is the end of the claw, will always stay parallel to each other no matter where it is in travel, which is really, really important for certain applications, right? Like if you had a basket that you wanted to move up, you can move it up and out, or you can move it up and back in. If for this example, one of the things that, like, there's the plastic claw that is in the First Global kit. One of the troublesome things with that is depending on the type of object that you're going to grab, it just has this type of a motion. So then it slips out from the end of it, when instead you want to kind of come around your object and be able to grab it from the sides. So it depends on the type of object that you're looking at doing. There are some clever things that you can do just all with the materials that are in your kit, and you can even supplement these with. Now this might not be game legal for any individual First Global game, but you can utilize REV materials with other materials that are near your home to be able to fashion things that are similar. So that's kind of a cool idea that we're able to do there.
So a question that I've seen pop up is questions about gears and how you pick the right types of gears. And we actually have a bunch of documentation on this, as well as documentation on a whole bunch of other things that I would like to point out. If you go to the REV website and you select technical resources, we have a complete documentation guide. Let me go ahead and show that to you guys. And in here, we have all sorts of pieces of documentation where you can learn more about individual topics and how they relate to designing your robot with REV stuff. If you want to learn more about gears, you can select the gear guide, and we show you kind of all the important things to keep in mind when you're designing with gears and understanding, more speed versus torque, all those kinds of things. Same thing with chain or with doing, different drivetrain designs. So wanted to go ahead and point that out for you guys.
Yeah, and so one of the things that's really great about the new website is the new system is it's all online, and you're able to export it as a PDF to save it on a local machine. So that's one large scale benefit. The secondary thing is right now, all of it is in English. We're actually working on getting it to a point where then we're able to start doing our translations. We would like to be able to get it into a lot of the languages that have been supported by First Global in the past, for example, Spanish and French, I know are two of the major ones that we do want to get done to make it easier for teams across the world to learn about this in their own native language, to be able to have that type of an impact. The one really great thing that we also try to do with those guides is there is enough information for like the practical, right? To get you enough info to get up and running and how this thing works. But then if you wanted to start doing a deep dive and you wanted to figure out like, what does modulus mean for like gears, right? If you wanted to figure out what some of these like, you know, bigger terms on like, what are these actual elements, we're continuing to add information that is more educational as well. That is more like technical engineering.
Yeah, technical jargon,
but it can help, but it can end up helping for you to have a better understanding and a better appreciation for the world around you, right? Like, and being able to understand the different things that are kind of going on. One of the other big things I'm kind of looking through here in chat is there, and I know that this was a question that was asked in the questionnaire that came out beforehand, but was around what is the best way of being able to transmit motion on a drivetrain. And like the big thing has been gears or chain is one thing that's been brought up before. There's the options of doing direct drive. There are pros and cons to any of these approaches. They're basically all trade-offs, but I think Frank has, I think, a pretty good example that we can kind of.
Let me show you guys. So this is a basic drivetrain that is being included in the FTC starter kit. And in this example, we are using chain as well as direct driving a wheel using the Planetary, which is a motor that we just came out with. We chose to do chain in this example because chain lets you have some more design flexibility when you're trying to go a long distance. If we had to do gears, we'd have a whole bunch of gears along the way. And the fewer axles you have, the more reliable your entire system is going to be. The thing I will tell you with chain is you need to make sure it's properly tensioned. A loose chain is going to skip teeth. The more a chain skips teeth, the more damage it does to the pulley, or to the sprocket rather, and then the more it'll skip teeth again in the future. So make sure that you are properly tensioned. And again, I'll point you towards the technical resources that we have published on the REV website. We have a guide on there on chains and sprockets that can show you some other little tricks to making sure your chains are more reliable.
And one of the really big things that we just kind of, this is usually a rule of thumb that I like to personally go by, is if it's going to be something that is kind of close in and compact, it might be worthwhile of thinking about using a gear to do that type of work. Or if you're looking at doing it over where you're going to need a wide spread, like you wanted to do a gear reduction or an abduction. I personally wouldn't recommend doing abduction, but if you have like
sometimes you have to.
But sometimes you have to. If you were to do a gear reduction after from your motor, that's another good way of when to use gears. As Frank mentioned, sprockets and chain are a really great way of going longer distances. It's also a really good way of being able to power linear motion in some cases as well. So there are some clever things that you're able to do in that case and then inside of that space. So that's a really kind of good setup there. One of the other things is we actually have a question here from chat. It looks like coming from Kamal, which is to avoid having, what do you propose to avoid having your servos heating up? We had some issues with this. So typically with your servos or even with motors, right? You can have a similar thing can happen with either type.
It's all about kind of the amount of power, right, that you are demanding from a particular motor or servo. If you look on the resources again, we have in our motor section a little table that shows you the different motor powers. So, for example, the HD hex, if memory serves, is around 14 watts. and the core hex is around 8 watts of power. So what that means is that is the most total power you can get out, regardless of the RPM, regardless of the torque. Some combination thereof is going to get you 8 watts or 14 watts. The closer you run it to that maximum power number, the hotter it's going to get. So with the servo, the closer you run it to its maximum torque, or its maximum torque is really where you'll see it. The longer you run it there, the hotter it's going to get. So you really want to design your systems so that it's not stressed out all the time. So you want to give it a break, or you want to create things that hold it passively.
Yeah, and another way of being able to do this is like we were showing the claw with the linkage. Linkages are actually a really good way that you're able to do that. You can use some of the servo horns, for example, that have come in the first global kit, and connect it to another object that then has a linkage to be able to make sure that your servo isn't the one that is.
Because it builds a mechanical advantage in there too, so that the servo doesn't work as hard.
Let's see here. All right, so let's see. We're kind of going through all this different type of stuff here. So
a question that I saw from Team India that I wanted to answer was, how do you make a smooth, fast, lightweight, sturdy linear motion mechanism? So there are a lot of ways to build the linear motion mechanisms. I would highly recommend you guys talk to each other on the Facebook group and kind of ask for pictures from other teams. I remember from last year, Team Hong Kong had a very cool linear motion mechanism that you guys should check out. But here's an example of a way to get a really cool, really smooth linear motion system going. So let me see. So one of the problems you can run into with the REV linear motion system, especially when you start to get really long, is the slides get really tight on each other. In order to make them nice and loose and smooth with one another, what you can do is, instead of screwing down the slider using the bolt that goes through this hole, what you can do is you can take a set screw and a nut, and you can put that behind the slider, and then use an end cap to cover the top of the extrusion. This will let your slider float a little bit, wiggle around a little bit in the channel, and that will help give you smoother, faster motion when you're doing a long slide. I will note that this will make your linear motion system a bit weaker, but if you want speed and you want it light, this is a way to achieve that.
Yeah, and so there are a number of ways to kind of be able to build that linear motion system. One of the other tips is you kind of have to when you're adding on like the side sliders that you're using, there is a little bit of a tuning process, right? Yeah. One of the big things that kind of a mantra, for a lack of a better word around here, is snug, not tight. Is that a lot of things, you get really excited, or you're trying to get ready for your next match, and you just start cranking down on something, and if it gets too tight, basically the whole system gets over constrained and makes it where there's a lot more friction being built up, which makes it harder for those linear systems to be able to move. So that's one thing there.
But I'll mention it again. If Team Hong Kong is on here, or if you guys can find pictures, the way they did their linear motion last year was very cool.
Yeah, so there's a number of really, really great ways of being able to do that. Let's see, we're kind of scrolling through some of our questions here to be able to see if we can find some other ones that I know we wanted to ask or answer. one of the things was actually around the T-slot screws. So I know that there was a couple of these questions around T-screws,
Yeah.
and how to use them, when to use them. Are they weaker? Are they stronger? What's going on with those screws?
So this actually ties in really beautifully with our first question, or one of our first questions, as to whether or not CAD's important. CAD is important because if you use CAD, you don't get yourself into a situation where you need to use a T-slot screw. Is a T-slot screw weaker than a regular screw? Yes, it is. But you also don't have to take off something in order to be able to slide it on, right? You can just drop it straight into your channel and rotate it to tighten things down. So that's why it exists. But if you CAD everything, if you design everything beforehand, then you don't need them.
So those are some things to kind of keep in mind. One of the other things too is if we kind of mentioned this earlier with design, if you do a little bit of planning ahead, that's usually a good way of being able to do it. What we're kind of hoping is, one of the questions that we had, I was skimming through the questions that we had that came in through the form, and there were a lot of questions about, what would we see in a future First Global kit? Now, First Global kits are kind of tied around the game, right? The rules are written where you have to use everything that is inside of that kit. Those are the limitations. The part of the the constraint of the game is you're limited to what is there. And that is kind of built around whatever any individual given challenge is. But we have come out with some new stuff. Frank already kind of alluded to this previously, as we have the Planetary Gearbox, which I'm kind of showing you here on this little view here, which is a pretty slick little device.
A lot of you guys have asked questions about in the forum about gears and how do you pick the right gears. And again, I'll point you towards our gear guide on the website, but the Planetary makes that a lot easier. Instead of having to use the big plastic gears to change your speed, you can do that with the different cartridges in the Planetary. Do we want to show the whole package?
Yeah. I'm looking for my.
So the Planetary is it's a lot like the 40-to-1 HD hex motor that you're used to, but it's a lot stronger, and it also lets you do any gear ratio you could want for your robot. So if you want a faster drivetrain, you can choose different gears in order to get that more easily. Or if you've got a lift that needs a lot of torque to go up, you can load the right gears into it in order to get that.
Yeah, and one of the things is it just gives more options and more flexibility as you're kind of designing things. One of the other portions that's kind of cool with the flexibility side is you can actually face mount objects to this. So like we have like questions that are coming, like how do you build like a good shooter? How do you build a strong lift for your robot? How do you do this? How do you do that? And a lot of this is a lot of the failures, at least that I tend to see with teams with the robots, is it's the connections of when the motor is being mounted and then it's connecting to something else to be able to transmit its motion someplace into a different area, or you're direct driving off of this and you're putting some very hard forces that are not they're normal to the shaft, which for a really kind of quick way is to think about this is that the shaft is expecting motion to be going in one direction, usually in a rotational one, but not in a down. It's not expecting it to be coming this way. So it impacts the gears that are in the rest of your gearbox and potentially can cause premature failure or damage. And so that's where we see a lot of problems from teams. So this is another way where you're able to just be like, if you have a wheel with you wanted a ball shooter, you could just attach to the end with a small gear ratio, maybe like a 3, a 4, or a 5-to-1, depending on how far you wanted to fling the thing, and some other types of ideas. So there are some
in the chat over here. Team Qatar just asked about loose gear meshing. So just like we were talking about, you want to make sure that you don't have any bending loads. We can sort of see it in the right here. Let's see. If I push down on this motor, you can see, pull up and down, you can see how that meshing changes for those gears. So you want to minimize any potential weird forces to happen on that motor. Another trick that I like to do is when I'm trying to get the mesh, I leave these two screws just a little bit loose, and then I push the gears together. And while I'm pushing them together, I then tighten the screws to make sure I've got a good engagement.
Yeah, and so there's some things that you're able to do along those lines to make sure that your gears stay meshed, making sure that everything is kind of snugged up there. Another thing, like with the motors as well, is that they can be a little heavy. So doubling up on your brackets is never a bad idea. Having it where you use some of these side mounting to be able to connect into another piece of extrusion, right? You don't need to just connect on one face. You can connect in some other ways. Building robots that are rigid is typically, especially around power transfer, is really, really important.
Absolutely, and a rule of thumb that we like to recommend is use, whenever possible, use 2 brackets to hold any 2 pieces of material together. Find a way to attach it in 2 brackets. That'll make it a lot stronger, a lot more robust.
Yeah, so whether that's like on pieces of extrusion that you're connecting together and you use an inside corner bracket with a 90-degree bracket, or you're using you're mounting a motor on, or any of those types of situations, if you're able to put 2 on there, or you're able to like directly connect one piece of extrusion to another piece of extrusion, right, can also help to give a little bit more support and more rigidity to any type of setup. There's been a couple of questions that have been around. Actually, Kamal has this good question. This is actually something that has happened. The HD hex motors, their gearboxes would leak some dark liquid, and it made much louder sounds in the previous year. So this is actually, so all mechanical devices will eventually start failing, and so there is lubricant that is actually inside of all of the gearboxes and grease. So that's basically grease is coming out of the gearbox. So when it gets to be running at a certain speed
and a certain heat,
the grease itself will come from being more like a jelly or a jam, like something that has a little bit more, it's more tacky, more thick. It will thin out and become a little bit more like a liquid and then start to leak out. So things that you can do is you can add a little bit more grease to your gearbox to be able to do that. But checking the gearbox itself before you do so, probably a good idea, making sure that those gears are still good and in place. As far as it goes with at the competition, us with REV, like our big thing is we like coming with a chunk of stuff to be able to make it where if you should be bringing the spares that you have in your kit with you to the event. But we also don't want to have anybody have a catastrophic failure. And usually someone like Frank will end up showing up in your pit and kind of help you be able to figure out if there's something that needs to be changed with your robot design or something else kind of going on there. There's been a few questions which have been a little bit more philosophical in nature. Like one of them is like, will robots lead to humans having less employment? And this is actually, and this is something that is actually, I actually tend to agree with Frank on this one. And a lot of areas like automation is really a big thing that has been happening. One of the things that we need to do, just generally speaking as a society, is making sure that that there is some sort of mechanism or way where just because you have an army of robots doesn't necessarily mean that.
Yeah, well, look at what Woody talked about in last year. The human creativity, the human element, the empathy that we bring to the table, that can never be automated.
And it can't really be replaced. So one of the things that I think is something for everyone to kind of take home is being able to make sure that you can find ways of being able to work with machines. So having the ability to do a little bit of being able to have some mechanical knowledge is beneficial. Having a little bit of software knowledge is beneficial. Understanding how things work is never a negative thing in this world.
And be a lifetime learner, right? Never be satisfied with what you know today. Always be trying to learn more, always be trying to discover more. Because in 20, 30, 50 years, the world is going to be a completely different place. And all of you are going to help shape that world. And it's going to be different, and you're going to have to learn new, different things.
Yeah. So let's see here. Like, there's some questions on there is some questions around like automation and autonomous programming within First Global. So as a part of the challenge, as a part of the game, there has not been a fully autonomous mode. This is something that we'll actually touch on in one of our other sessions is going to be on programming, but it's how to create automated, basically automated routines so that you're able to have it where it's easier for your drivers to do things. So like you hit a button and you go to the high goal, right? And you don't need to move your arm and you don't need to move each one of those individual pieces. You just need to move you press one button and the robot can do it for you by using some of the sensors that are in the kit, using some control algorithms and that type of a thing to be able to kind of go that direction. This actually reminds me, there was a question in here about maintenance of pieces and systems, but actually we know that a lot of you are traveling from all across the world to come to these competitions. Various conditions that the robots are stored in or while they're traveling, and you may come to the event or you might get your robot home from an event and you might see some things. So one of them, I believe this was from Team Egypt, was mentioning that on their linear motion system, their pulleys started to get a little bit of rust on them. So like if you can easily solve this by using you can use a rust remover, or you can use a little bit of oil or some other type of lubricant
to protect it. And remember, if the outside is a little rusty, that's not a big deal because the inside of the ball bearings is what matters, right? So as long as the inside is in good shape, and it is because it's a sealed bearing, then you don't have to worry about it. So the rust is really just cosmetic. Same thing with rusty chains. It's okay. It's not a big deal. Just put some oil on it, and
kind of continue
just keep going. It's not going to break anything.
Yep, and it's also one of the reasons why it's one of the reasons, not the only reason, why a lot of our products are made out of aluminum. Is aluminum, while it can technically oxidize, it can rust. It's very, very difficult to do so, especially once it's been anodized the way it has.
Anodizing is pre-rusting.
Yeah, basically. So that's some of the other things. One of the other big questions that came up was basically a lot of stuff that was around. We obviously we're not sitting here doing a technical call, right, about this upcoming 2020 challenge. There is a global pandemic that's going on, and one of the questions that actually was brought up by multiple teams is, how do we work as a team during this time? Like, what are you guys doing at REV during this time? What precautions are you taking and putting into place? And how are we able to still work towards the same goal within our communities, even though we might not be able to meet in person? So one of the things that we've done here at REV is we use a lot of virtual tools. So for example, like email is one that's really, really popular amongst us. But I know that we use like chat services are also used by different folks in the company. So you can use things like, there's WeChat is one, there's, Google has their chat services, Skype has theirs, Discord, Zoom. Yeah. Find one that's useful and available within your country, and that's a good way of being able to start to be able to have ways of doing communication. We mentioned XDesign is a collaborative online tool for CAD design, which that's another good way of using it.
It's going to make a huge difference for your teams to use that tool and get familiar with it. It'll help all aspects of your robot design process.
And so there are some other ways of being able to do that. And then also we would highly encourage that you probably try to not be in large groups, but typically teams are a little bit smaller. So if you do have to meet to hand off equipment or things along those lines, wearing masks, staying outdoors, if you do have to meet, is other ways that you're able to kind of still get a little bit of that camaraderie while being able to stay away, staying safe. Following health procedures is another really great way. But just because this is one of the things that I think we find amazing is we're sitting here in Texas, 3 o'clock on a Thursday, and we're talking with a bunch of you all from all across the globe. And so there are online tools are really, really powerful. Being able to use those. One that I also really like to use for teams that I've been involved in is a software program called Trello, which does it's called a Kanban view, but basically it's a way that you're able to track tasks and things that you're able to do and move them along to update other people on where they're at in their process. We use something similar to that here at REV to kind of track our things, but that's one thing that you can kind of keep in mind as you're going.
So Team Venezuela was asking for high-speed applications, whether it's better to use gears or sprocket and chain. It's an easy one, gears. The higher the RPM, the better the gears. Then another question that has been coming across from Team Columbia, if you're running into a creative block, how do you cope with that? It's really about that iterative process. Go back to your assumptions, go back to your requirements, go back to your limitations, and view your solution within the lens of those assumptions, of those limitations. Are your assumptions valid? Are you guessing correctly? Test those questions, test those assumptions. And there's also a big element of just play. Hit things together, see what happens. Don't be afraid to just spend some time hitting your head against the proverbial wall to find a solution.
So we have time for probably a couple more questions here really quick. We're going to kind of do these a little bit more rapid fire. There's been a couple of different questions around programming languages that are available on the Control Hub. Are you able to use, Raspberry Pis or other things with that? So as of right now, things are limited to blocks, onbot, and onbot Java with the Control Hub. We are always investigating other ways of being able to add more languages to it to be able to make it a more verbose system, because we want to be able to have anybody from the ultimate goal would be to have anybody from any language, like with using any programming language with a device. But at this time, it's currently blocks in Java. The application itself, since it is an Android-based controller, is actually written in Java. So that's part of the reasoning behind there. There's been a few different questions which are like, how do you choose what mechanical method to carry weight? Like, what's the limit of these things? And a lot of the things is your limit is actually just the torque that the motor is able to pump out.
14 watts, you've only got 14 watts. How do you apply them?
Yeah, and so you just need to be able to figure out that type of stuff. There's been some questions around tutorials for constructing robots and building things. We do have guides. Docs.revrobotics.com is our docs website. Our technical resources tab on revrobotics.com has a number of them. We're going to be working with our folks at First Global to be able to get those in some different languages, as well as get them out to you all to be able to give a good starting point, especially with a chassis. Being able to drive is one of the key elements every single year. For the most part, I think you would need to move the robot almost every year that I can think of. There might be a game where potentially that would not be the case, but more than likely it would be.
Team Bolivia, communication.
Yeah, that's always that's always
how you do
big
that.
one.
You work the problem and you talk through it.
Let's see here. And then there's been a couple of other questions that have been kind of floating around about what object. We kind of touched on this earlier. What objects would be in the kit for next year? As of right now, we don't know. Once the game kind of gets designed and finalized, that's when the kit kind of starts getting put together, so that we're able to kind of optimize things for that game. But we have added new equipment into those kits every single year. So for example, new iterations of like our chain tool have been put in. We put in the hinge kit. We varied the number of like linear motion kits you've needed, depending on what that year's challenge has been. New servo horn adapters, gearbox changes, motor quantity changes. So there are a number of these types of things that might adjust over time. Last year during the challenge, we had a driver station, a device that we had a number of teams utilize instead of the Amazon tablets at the event. We're continuing to develop this. One of the big things is that, and this was actually mentioned within the chat a little bit, is like, how does the Control Hub operate and what's the point of a device like this? And the really big thing is it allows us to control. So from a user experience, it allows us to make things easier for you all to get up and running, which is a really big thing. But really the large scale secondary thing is when you have 190 robots all in a room and they're all trying to use the same amount of bandwidth. It's like you have a cylinder. The cylinder is only so big, and you just keep pouring more and more robots into that cylinder that are all talking to each other. Eventually, some of that communication gets lost. It overflows, and then whose communication is getting lost? How is that getting lost? So it gives us a lot of ways that we're able to change and tweak and update things on both ends with both the control hub and the driver station to be able to kind of do cross communication in that way. And then the other really nice thing is, at least with the first global tournament, we are able to have basically power provided at the field, because like the number of teams that we had at the event in Mexico that would come to us with tablets that were dead, and we would have we'd have 15 of them stored randomly in the arena that you'd have to grab to be able to get them to be able to play the match. So it gives a lot of advantages in that type of a way. So we're really excited to see. I'm really excited to see what 2021 is going to look like, and what challenges await for us around that corner. Potentially what that kit is going to look like, what that game is going to be, and where we might be actually going.
And to answer Team Qatar's question, yes, absolutely. We're always amazed by different systems that teams come up with. I already mentioned Team Hong Kong and their linear motion. Team Singapore from Mexico City had a very cool 4-bar mechanism that y'all should check out. There's, those are two that jump to my mind. But there are awesome robots every year. Look at the pictures and pay attention to the details. When it comes to really cool design, big complex designs are absolutely very cool. But if you look at the details of how they got to that complex design, or how they achieved simple things with clever details, that's where you'll see really inspiring design solutions.
And I think, hold on 1 second here. Okay, so I think we have time for a couple more. So let's try to do St. Kitts and Navitas is asking, what would you do if the shaft on the hex motor is too short for the gears to be attached to the end? So we kind of talked about this a little bit earlier, but you don't want to be, the term is cantilevering. So you don't want to
be all the way out here.
You really don't want to be all the way out here off of your gearbox. You actually want to try to be as close to the inside of the gearbox, to the face of it, that you can be, because it basically allows for the rotational force and not a force normal to the shaft, or otherwise like sideways to it. Basically, it wants to roll. You don't want to push down on it from forward, backwards, around and round. It wants to just spin. So if that's too long for you to be able to fit a gear on there, one of the ways that you can do this is you can have your gearbox, you can have your motor running to another shaft that has a gear on it, that then has a shaft that has a gear further up that shaft, probably with spacers or a shaft collar somewhere in between to be able to condense that then transfers the motion to your final stage of what you're looking at accomplishing. And if you make all those one-to-one, then it will be, basically just the efficiency of the gears is basically all you're worrying about.
And if you're just trying to extend the shaft in order to get it to some other place, I believe it was Team Iraq had a very cool extension that they made, coupling rather, that they made for the 5mm hex shaft using the hex hub strengtheners. So if you check out their robot from, I believe it was Mexico City, they had a very cool little solution they came to.
Yeah. So there are some other ways that you're able to kind of do there. One of the things, Stephanie, you're mentioning to me something, and
I wanted to point out quickly that if you go to the resources page on the First Global website, we have a bunch of different robot simulator software, things that are free for you to download. Our sponsor SolidWorks is also offering scholarships to all students to download their software for free. The technical guides that Rev was mentioning on their website, they're all linked off of that. So go to, I think it's first.global/resources, and it'll all be on there for you guys.
Yep. So there's a lot of great resources that are there, and thanks again to all the sponsors that help to be able to give the software and a lot of this type of stuff available in that way. And with that, I think there are a few more questions that are in here, but we have a number of other systems. I think there was one actually. Do we still have that pulley thing? This is the one thing that I think we didn't actually hit on.
Yeah.
One of the questions that we ended up getting, that we actually get often, is when do you use round belt and pulley, the round belt with the pulleys, and should you use that instead of sprockets and chains or instead of gears? And this is one of the things that round belt and pulley is really good for, is for picking up game mechanisms.
Yeah. So this is an example of a conveyor intake mechanism. You know, this would be mounted kind of in this orientation on your robot, and a ball would get sucked up and in and kind of carried up through here. And this is using the polycord. One of the questions that I saw with the polycord is how you join the end pieces together. In your polycord package, you should have received, let me, 1 second, let me pull up the REV website and show you guys the specific. So here, let me share the screen real quick. So you should have received a package of these brass barbs. In the end of the polyurethane belt, you will see that there is a hole, that it's a hollow tube. And what you do is you push that barb into the end of the polyurethane tube. Tip I recommend is to warm up the ends of the polyurethane in some hot water, and that'll make it easier to push them together.
Yep, and it is having some warm water, and then also getting something to be able to hold on to the barb, like whether it's pliers or something else.
Yeah, pliers, vise, all that helps.
Something that you're able to kind of hold on to it with can definitely help. The warm water is actually an A+ tip. It warms things up just a little bit, allowing it to expand, and then you can just jam the plug in there and kind of go from there. But that was one of the things that we ended up having questions about, is like, how do you end up using those things? And Frank and I were actually talking about this earlier today, and we almost forgot about it. So that's a bad on us. But anyway, with that, I think that covers most of the questions that we got for now. I know that we have a ton more that are more specific on design related for CAD, and some more that are more programming specific. And we're going to talk about those in the months to come. But yeah, Stephanie, do you have anything that you wanted to add?
No, thank you everyone for joining us, and stay tuned for the details on the next one we're going to be having.
All right, so hopefully we'll be seeing you guys soon. So goodbye from all of us here in Dallas, Texas.